Sorry.
Yeah. Okay. Hello, I'm Jessica Acosta.
I'm Brianna Kane. And this is our limiting reaction group 1.
So, am I sharing my screen or no?
Yeah.
Okay.
So first thing we're going to talk about is how we got the actual mass precipitate and the percent yield calculations. So in order to present percent yield, we had to do the actual mass. So to get that, we took the molarity of the limiting reagent, which we'll talk about later, for each of the trials, and divided it by the volume in liters of the limiting reagent. We had milliliters at first, so of course we had to do our stoichiometry from milliliters to liters. And then we took the molarity and multiplied it by the molar mass of the limiting reagent and got the actual mass of the precipitate. Then from there, we took the actual mass, divided it by the theoretical mass times 100, and that gave us our percent yield for each of the trials. So for the first trial, our limiting reagent was the Na2CO3. So of course, that was the one that we used for the stoichiometry and for the calculations for the percent yield. And then for the second and third trials, the limiting reagent was the CaCl2. So of course we use that for the stoichiometry and calculations for the percent yield. And then from there, we balanced an equation and we were able to get what was going to go in our beakers.
So for the beakers, after we balance the equation, obviously the CaCO3 is going to be the solid, so that's going to remain at the bottom of our beakers due to there being the substance at the bottom, which was the white substance, even though the water was cloudy. And what's going to be floating in our H2O is going to be the Na and the Cl, and that's going to be for all three because they all were basically the same, just more of the substance or more of the liquid that was added to it. And does she want us to go over all of this too?
Yeah, all the questions.
Okay. So if sodium carbonate is the limiting reagent and calcium chloride is the excess, which ions are present in the supernatant? I put limiting. I don't know if that is correct.
I think that's the liquid part of our beakers, so I think that would be the NaCl, 2NaCl. I believe. Don't quote me on it.
Then for the next one, what would happen if you added CaCl2 to it? If you added CaCl2 to it, then it would basically do nothing. It would just add more of it and it'd be more concentration of it, but there wouldn't be no reaction out of it. If you added Na2CO3, then you would produce more of the solid substance, which is at the bottom of the beaker. So then there'll be more at the bottom of our beakers. And if calcium chloride is the limiting reagent and sodium carbonate is in excess, which ions are present in this, then it'd be all these three. If you were to add more, then it would produce more of the solid as well. So basically there'd be no reaction again. And if you were to add more of NaCO3, then it would be more of a reaction, or it would not cause a reaction. It'd be the same thing as above. It would produce more solid. So we'd have way more solid than liquid, if that makes sense. Should we go over the table?
Oh, yeah. So in the trials, where predicted reagent and access for each trial First one was the CaCl2. Second and third was the Na2CO3. And then observations after adding. So for trial 1, after adding the CaCl2, it was clear. And then after adding the Na2CO3, it was cloudy. And then reversed for trials 2 and 3.
And then go over this one.
Oh, observation after adding the Na2CO3 was cloudy for trial 1. And then for 2 and 3, it was clear and clear.
And this concludes our briefing over our assignment. Let's see.